that this summer.
Okay, so you haven't taken anything. All right.
No.
Well, this will make you feel good, I think, because you'll see that it's really the basic math. Now, these start off easy and get harder, so don't think they're all this easy, but let's start with number 1.
C.
Okay. Number 2.
H15.
Okay. Notice something about this problem. They give you a lot of information that you don't need. We don't care about the oranges, the apples, or the strawberries. We only care that it's 6 people versus 18 people, and 6 people needs 5 pairs. You picked up on that good. But it's a good lesson is that just because they give you information doesn't mean you have to use it. Okay? How about 3? Hold on. I'll get this out of the way. There we go.
D.
Good. Let's go to the next page. What I like about the SAT and the ACT is it is the common core mathematics that you need to know, as opposed to what they teach you in your classes. Like geometry, 2/3 of what they teach you in geometry class, you don't need to know for the ACT or the SAT. So this really focuses it.
All right. And then 12. I actually don't remember how to do that.
What is the circumference of the hat? That's basically what they're asking, right?
Yeah. I just forgot the circumference formula.
All right, let's go over those, because these are 2 of the most important formulas in all of math. The area of a circle is what?
Isn't it pi radius squared?
Pi r squared. Now, I don't care what you have to do to memorize this, but memorize it. One of the things that I use is, well, pi are round. They're not squared. That, believe it or not, helps me memorize it. And then the circumference of a circle is those same 3 numbers, only bring the 2 down and stick it in front. 2 pi r. These 2 formulas, make sure you never forget them again. Okay?
Mm-hmm.
So, what's the circumference of this hat?
So it should be 8 pi?
Uh-huh. Number 6.
It would be G.
on. This problem is very interesting in that it's not very hard, but what is unique about it, and let's talk about it, is that you have two variables in the problem, x and y. And every answer has an x and y in it. This lends itself to picking numbers. Okay? And let me explain what I mean by that. Is since they don't tell you what x and y have to be, we can pick any number we want for x and y. In other words, let's let x equal 2 and y equal 3. Okay?
Yep.
So if x is the number of large jars, how many olives are we going to need to fill 2 jars of x?
96.
How many olives are we going to need to fill 3 jars of y?
96.
So the total olives we're going to need is 192. Now, the trick is to find which answer represents 192 when x is 2 and y is 3. Does G?
No.
Does F?
Yeah.
Aha. So even though we didn't know how to go directly from this to this, by picking numbers, simple small numbers, where we could actually figure out the answer manually without any difficulty, it gave us a chance to figure out which was the correct answer. And don't forget that. That is a key technique for solving some of these problems. It's called picking numbers. You basically have an algebraic way to do these problems, which is what you're inclined to do. But you also have back solving and picking numbers. Back solving meaning you take each answer and just test it and see if it's the correct answer or not.
Okay.
All right. If f of x equals 3x squared plus 4, tell me what f of 2 is.
16.
Okay. Tell me what f of x plus 1 is. Step by step.
So it's 3 parentheses x plus 1 squared plus 4.
Expand it.
So it would be 3x x squared plus 2x plus 1
Good.
plus
Keep
4.
expanding it.
3x squared plus 6x plus 6 or plus 10.
3 times 1 is 3
Oh, 3
plus
yeah,
4.
plus 4.
Final solution. Number E.
Yeah.
Okay? You're going to do good on this test, Mitch. Trust me. I've worked with enough students on SAT or ACT that I can tell pretty quick. And,
You kind of feel more or less like not simple math, but
well, these are going to get harder, but this gives you a real good idea of what kind of math you actually have to know. I mean, your SAT and your ACT scores are going to be as important to you as your GPA. Every bit as important. If you had to choose which one to do good on, which one to do poor on, I'm thinking you want to do good on the ACT, SAT test.
yeah.
How do we do this problem right here? Now remember, you can use a calculator. However, I'm going to tell you that there's not really very many problems where it is a benefit to use a calculator. Out of 36 problems, I'm guessing 1 or 2 is going to help you to use a calculator. I don't think this is one of them. What kind of calculator do you have?
Inspire.
Not quite sure what they do with the Inspire on the SAT, ACT test. The Inspire has a lot of capabilities on it that they're not going to let you access. They're going to force you to turn off when you take these tests. One of them is like the ability to factor. Let's say you have full capabilities of the Inspire on this problem. What are you going to do?
Well, I don't actually know, because I don't know everything that I can do on the Inspire, because they don't really teach us how to use it.
There's one capability on the Inspire and the TI-84, and that is switching between fractions and decimals. But I'm not sure that's going to be a capability you're going to be able to access. I honestly don't think you are. I think what they need you to do here is be able to add fractions. So let's assume that you have to be able to manually add fractions. How are you going to solve this problem?
Turn all the denominators to 24, and then you figure out how much you have to multiply each side to get there.
All right, that is a good solution. However, the key part here is we want to add just the fractions. Forget the 5, the 3, and the 1 for a moment. Those add to 9. So what we really have is this problem. And you're correct. The common denominator is 24. So let's go. How many 24ths is 5/6?
20.
How about 5/8?
15.
And 1/3?
8.
What do we got?
43/24.
What's the answer?
It's 10, 19, 24.
Very good. Okay, and that's the way to do it. Now, you have some choices here. We didn't have to do it that way. We could have done it a much tougher way, which is to convert each of these to improper fractions. In other words, this is actually 35/6. This is what? 29/8, and this is 4/3. And we could proceed the same way. The problem is that that gives you much bigger numbers. When you find how many 24ths that is, you're all of a sudden dealing in real big numbers, and it's real easy to make a mistake, even though you have a calculator. So the real key to this problem is to separate out the fractions from the whole numbers and just add 5/6 plus 5/8 plus 1/3.
All right.
Even though your calculator might support doing this, 5/6 plus 5/8 plus 1/3, getting a fraction, what was it,
3.
3/24, And then that, you can convert that to decimal automatically on a calculator, but you can't really convert it to 1 and 19/24. So you really have to know how to do that. So here's a problem where people who don't know how to do this and who want to rely on their calculator might have a problem. It's not easy to do this on a calculator. All right. I usually think it's a good idea to draw a picture on these problems.
Yeah.
Walks down the street directly from the school to his house, going this direction. Candy store is 2.35 miles from the school. And the grocery store is 3.4 miles from the candy store. Well, there's the candy store. Here's the grocery store. And this distance is 3.4 miles. How many miles is it from the grocery store to Jimmy's house? If this whole thing is 10 miles. How far is it from here to there? X.
Would it just be 10 minus 3.4 minus 2.35?
Yes, which is 4.25. Notice what they do in this problem. They try to kind of trick you by their wording. They start out by saying his school is 10 miles from his house. But then they start walking down the street, and you got to make sure you're going from the school towards the house, not from the house towards the school. So in this problem, a picture really helps. A picture, if your life depended on getting the answer to this problem right, you'd draw a picture and you'd get it right. There's really no way to mess it up if you draw a picture.
All right.
Number 10.
Right. So it would be F.
Good. Good. 10 to me is a critical problem as to how somebody solves 10. Because you can take a wrong strategy here that really misleads you. If you try to solve 10 by saying, well, she gives him 3 new pieces the first week, he's going to solve 2 of those, he's still going to have a piece to earn, and you go that route, you're totally screwed. But if you do what I suspect you did, which was to see that 3 new pieces for 4 weeks is 12 new pieces. 12 divided by 2 a week is 6.
Yeah, that's what I did.
That's the way you should do it. But not everybody sees that. Some people try to work it out going week by week, and that just is slower and maybe won't even give you the right answer. So 11.
Or how I would do it would be 180 minus 35 minus 65.
That's it.
So
This is the most basic principle of geometry, is that the sum of the angles of a triangle add to 180.
So it would be
All right. This is what I call an average problem. This gives a lot of people trouble, but if you take the right methodology, you'll never have trouble with this.
I'm not really sure how to solve this
When
correctly.
you have what I call average problems, or you could call them arithmetic mean, all of them, and I mean every one that I have ever seen, is something that's going to require you to look at the totals. So when you see an average problem, think totals. What's the total of Randy's score in the first 3 games? Total scores. 505.
Yeah.
Okay?
Yeah.
Now, for 4 games, if you want to average 175 for 4 games, what's your total score need to be?
680.
Well, 4 times 175 is 700.
Oh.
So what score do you need to score on game 4?
$195.
Exactly. And notice that what we do not do is compare averages. In other words, we could figure out an average for these 3 games, easy enough. You add the 3 numbers, divide by 3, and we could maybe try to compare that average with this average of 175. That is not ever what you want to do on these problems. When you see an average problem, and you will see them, there's 2 or 3 of them on this test. When you see an average problem, I want one thing to come to your mind, and that's total score. Totals, 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 totals. You answer all average problems by figuring out totals, including the part that says in order to score 175 average over 4 games, you need the totals for that. It's 4 times 175 is how many total pens you need for 4 games. I'm going to draw a little picture here. And for a problem like 13, it's exactly what you want to do, is draw a picture. Well, here's one point. 3, 5. There's another point. 0, 2. There's a third point. Says, draw a triangle about those 3 points. Well, there's my triangle. Which answer fits that triangle?
E.
Picture is worth 1,000 words. Sometimes you just got to draw a picture. Although maybe not for you in that case. You might have been able to get that without drawing a picture. All right. This says, what is the sum of the solutions? So we have to do two things. We have to solve this quadratic. We have to come up with two answers and add them together. So it's a two-part problem. So how do we solve it? This is the kind of problem where they're not going to let you use the factoring capability of your Inspire. So don't use it while we're doing this either.
Yeah.
What's the first thing you can do to simplify this?
Take 2 out of everything.
Divide both sides of the equation by 2. Okay, now what? How do we solve quadratics that are equal to 0?
Factoring?
Absolutely. This is one reason I have tried to spend time developing your factoring skills, is because you need them when you take these tests.
Alright. So equals, or then
That's the first step. Split up the y squared. What's the second step? Or what's the answer? I don't care if you know my steps or not. If you know how to factor it, that's fine. What is the factors?
So it's -3 +1.
Good. What is the product of their solutions? What are the two?
-2.
What are the two solutions?
Oh, 3 and -1
So their product?
is 2.
Product. Oh, excuse me.
Oh.
Sum. You're absolutely right. It says, what is the sum? You're right. It's 2. Answer J. Most of the problems on the SAT or ACT, despite what you've seen so far, you've seen the easy ones, but most of them are generally two-step problems. You can't answer them by just doing one thing. You have to do two things. In other words, we have to solve this quadratic to get our two solutions, and then we have to add the two things together. That's very typical of the test. $15, you got a calculator in front of you?
I don't have my Inspire, I just have my phone.
Well, you don't really need a calculator. I mean, if you had a calculator in front of you, then that'd be the easiest way to answer 15. You can use a calculator to do these. 7/8 is 0.875. And here, I don't have the Inspire online, but I got this. You ever seen this calculator?
Yeah.
7 divided by 8, 0.875. And that would be the easiest way to do it. In other words, whenever you can use the calculator to your benefit, you should. It's just that I'm telling you that most of these problems, the calculator doesn't really help. They don't design this test so that people who are really good with their calculators can do well. They kind of design it so that the calculator really doesn't help you. Let's do this one last problem here. You know what? I have a 4:30 session also. Let's end it at 15 and we'll pick up 16 next time. 16 is a key problem. It's what I call a marbles problem. And 16 is a classic example of where you should use back solving. In other words, 16, rather than trying to do it algebraically, which you could do, I'm sure if you spent enough time on it, you could calculate or figure out what all the equations are. But it is so much easier to do by back solving. You know what I mean by back solving?
Yeah.
Taking the answers and seeing if that's the correct answer or that's the correct answer by working back through their premises here. And you could tell whether 20 is the right answer, or 16, or 25, or 30, or 32. And that's the best way to do that problem. I'm going to make a note that we ended on 15, and the next time you don't have anything specific to work on, we'll come back and work on these.
Yeah.
All right, Mitch? All right. I got a good feeling. You're going to do good on this test, so I feel good about that. You got some good math skills. I'll talk to you, let's see, next Monday, right?
Can we do on Tuesdays? Because I have golf now at 4 o'clock.
Oh,
So.
you lucky dog. Yeah, so I'm going to move you to Tuesdays permanently.
Yeah.
So are you golfing at this place that's advertised in the King Carl paper where it says Littleton Golf?
No, I go all the way out to Lone Tree to do it.
Really? Okay. Because there's some new place called Littleton Golf, but it doesn't give an address. And it acts like you can do it indoors, but it may be the one that you're using at Lone Tree.
Maybe.
Yeah. All right. I will talk to you next Tuesday.
Thanks.
All right. Bye-bye.